Scaling Mount Olympus, Prometheus, one of the great titans, hatched a plan to steal an element Zeus kept from men in fear of them having too much power. Fire, the only thing keeping the mortal from the immortal. So he snuck into the workshops of Hephaestus and Athena, hid fire in a funnel stock, climbed back down, and gave fire back to the humans, giving them domination over the natural order. Enraged over what happened, Zeus captured the great titan and sentenced him to an extreme and eternal punishment. Chained on a frostbitten cliffside, Prometheus shouted in fatigue, agony, and despair as vultures feasted on his liver for the rest of eternity. Many are familiar with the classic tale of Prometheus, with some, including Frankenstein author Mary Shelley, treating it as an ominous warning to man's growing scientific capabilities. In recent years, and with the emergence of gene editing technologies, the conversation of man wielding control over life itself has sparked once again. But to understand the nature of the topic at hand, we must first consider the history that came before it. Even in ancient times, civilizations had forms of biotechnology through the usage of enzymes of bacteria to create certain products. Cheese and yogurt are good examples, both of which were invented around 7 to 8 millennia ago in Mesopotamia. With the help of two different lactic acid producing bacteria, farmers back then were able to convert their milk into cheese and yogurt. Other examples also exist, such as the creation of the first alcoholic beverage 7,000 years ago by the Chinese, with the help of bacteria that fermented wheat into alcohol. Another would be the usage of yeast by the ancient Egyptians, effectively using its enzymes to create a gas that expanded the bread, giving it its signature loafy texture. Societies were even manipulating the genetic makeup of their livestock and crops through selective breeding. For example, Mesoamericans manipulated a plant called teosinte into the form of corn that we are familiar with today. These examples show that the usage of bacterial enzymes, as well as the manipulation of genetic makeups, are no recent thing. Nonetheless, man would continue to hone his ability to control life during the Renaissance. Every living organism on this planet is made up of tiny cells unseeable to the human eye. Mankind would not know about its existence until 1665, when Robert Hooke, upon improving his compound telescope, saw a world so tiny yet so massive when he placed a piece of cork under his microscope, calling them cells due to the resemblance to cells in a monastery. Later, Antoine van Leeuwenhoek discovered bacteria and protozoa, which he called back then as animalcules. It wouldn't be until centuries later that proteins, molecules known for their fundamental role in carrying out functions in the cell, would be discovered in Sweden by Jon Jacob Berzelius in 1838. Then, Swedish chemist Johann Friedrich Miescher would discover DNA, the source code of life, in the 1860s. While discoveries would pave the way for further scientific exploration, this period of time wouldn't be restricted to just discoveries. Edward Jenner created the first vaccine in 1796, when he used cowpox to vaccinate someone with smallpox, the world's most deadly disease at the time. Carrying on the torch of vaccines, French scientist Louis Pasteur in the 1880s developed the first vaccines against cholera, anthrax, and most importantly of all, rabies. These show man's capability to manipulate life in order to conquer even the most frightening diseases. As history shows, however, man wouldn't stop there. Throughout the 20th century, all fields of science flourished, and biotechnology was certainly no different. Almost by complete accident, British scientist Alexander Fleming in 1928 discovered a compound called penicillin, which would attack any bacteria that comes in contact with it. The discovery of penicillin would kickstart an age of antibiotics that would vastly improve people's lives for decades to come. Later in the century, in 1953, James Watson and Francis Crick would introduce to the world the structure of DNA, the so-called source code of life, but not without the significant help of Rosalind Franklin, who was unfortunately unattributed in the Nobel Prize award for it. Nonetheless, their study revealed key insights into the nature of genetic material in DNA that would form the building blocks of biotech later down the line. Aside from groundbreaking discoveries in research, the 20th century witnessed genetic engineering becoming more prevalent in the modern world, with the introduction of hybrid corn into the mainstream market. Plant geneticist George Harrison Shull bred several varieties of corn in the 1920s that yielded more per acre than their old predecessors. Hybrid corn then became the mainstream in a heartbeat, constituting almost all corn growing in the Corn Belt by the 1960s. Following that, advancements in biotech would continue to occur. Scientists Stanley Cohen and Herbert Boyer in 1973 would splice DNA from one bacterium to another, giving the world its first recombinant bacteria, which would later find useful applications, such as synthesizing the growth hormone or even human insulin. With this knowledge in mind, scientists in 1990 devised and performed the first ever approved gene therapy to treat an immunodeficient 4-year-old girl. Scientists would then carry on, cloning the first ever mammal, a sheep by the name of Dolly, from the mammary gland of her mother in 1996. However, as the field of biotech accelerated, more and more would become suspicious, questioning its ethics, moralities, and the very concept of manipulating life itself. At first, the concept of golden rice, a GMO rice that would be rich in vitamin A, seems like a great idea. It would solve worldwide issues regarding malnutrition and can even open the door for more nutritious GMO variants. Ingo Porteous and Peter Bayer in 1993 thought so, and developed golden rice, which was set to be approved in the Philippines by 2013. That year, however, 400 protesters attacked the fields of golden rice, claiming that it was a danger to both the public health and biodiversity. The golden rice incident was just one of many incidents that showed society's suspicion regarding biotechnology and genetic engineering. Suspicion and controversy would continue to simmer in the 21st century when scientists discovered a gene-editing molecule that would change biotechnology forever. After the molecule itself was first discovered in 1993 and its function was described in 2005, scientists at MIT harnessed for the first time the gene-editing capabilities of CRISPR-Cas9. Experiments using CRISPR-Cas9 would carry on until Chinese scientist He Jiankui in 2018 modified the genomes of 2 babies to be resistant to HIV. The world would be shocked by not only the experiment, but also the concept of even editing humans to be stronger, spawning controversy and debate from all corners of the world. This experiment would later be condemned by the wider scientific community. Suspicions about CRISPR-Cas9 and gene editing technology continue to remain in the public's minds, though the technology has already resulted in advances in the field of biomedical research. The myth of Prometheus acts as a forewarning for mankind as it evolves through scientific advances. Question is, will we soon be a Prometheus punished for his hubris, or Prometheus unchained and wise? Great changes are coming to society if biotech continues to advance at the rate that it is today. With great power comes great responsibility. Now is the perfect time to discuss ethical issues and problems so that the next chapter in the history of biotech will be a good one.